you audible, guys? Are you audible? Okay, right. So guys, in the last session, we checked out, what we called the introduction part of your PLSQL. We started in the last session. Okay, right. And now we can go for the next the main topics we are entering here. So one of the topic is called as cursors. Okay, the one of the topic is called as the cursor. Okay, so basically, okay, cursor. Okay, what exactly here? And this cursors, okay, how we can go to use it, okay, purpose of cursors, why we need to declare this cursors, and cursors, why we want to declare, yes or no? So this kind of doubts will be come to us, okay? And now simply you can understand, guys, here. So cursor is nothing but it is a one temporary, okay, memory, otherwise it is called as a, okay, it is a, okay, one temporary memory, otherwise you can say it is a private SQL private area also we can say, otherwise a workspace also we can say. It is a private, it is a temporary or else, okay, SQL private area or else it is a workspace. It is a workspace. It is a workspace. Okay, now. So, but here, why, sir? Why we need to create this temporary memory? Why we need this temporary? Why we need this private memory? Why we need this workspace? So means the reason is what now? Observe. Generally, okay, in the morning session, morning batch, okay, we started morning batch today. So that explanation, the diagram I'm explaining here, same diagram to save our time. So in morning batch also started same cursors, right? So generally, what it was happened in the first diagram, carefully focus on this, guys. First diagram, you can focus it. So in this is general operation, right? Okay, so when you didn't create one temporary workspace, the user is not created. What it was happening, sir, means we all of you know, whatever we create a table and whatever the data we are storing under table, and those tables we are directly storing under where now databases. Generally, the tables are directly stored under databases. So that means your data was there under database memories. Your complete table data is there in database memories. Okay, for example, suppose user need to access some data, like you want to give select a star from EMP, otherwise select a star from EMP, some conditional level, whatever it is. One, if user want to access the data from the database memory, we need to send some request. The request in the form of query. The request in the form of query. So that request we are going to be sending to server. Server, what it will do, guys, here, based on user request, server will go to database memory. And as per the query request, the data is going to be searching and finding, and the finding after found the data, it was sending to user applications. That means what it was happened, every user request is going to server. Server will take user request. As per user request, the server will go to database memory and the searching. And after searching your data, once it was found, the founding data again sent back to user. This is every time it was happening. So now you can observe. So guys, here that means one user request will be processing. If you just imagine here, there are number of users sending number of requests. Yes or no? So here not only one user in real time world, There are a number of customers, number of users are doing transactions. Number of users are sending, the lakhs of users, thousands, lakhs of users, they're sending requests to your servers, database servers. So these all requests will take. So suppose there are 100 users are sending query requests to your Oracle server. Then those 100 query requests will take by Oracle server. User requests, 100 user requests. Okay. So it was going to be searching and finding data and responding. That means sending back to 100 users. Sending back to 100 users. So in such a case, what happened, guys? User requests or increases, automatically database burden also increase. Then database burden is also increased, then performance will be degraded. This is generally it was going to be happening. Okay, now generally it was going to be happening. Okay, now so every user request will go to server directly. Server will go to database and searching and founding. After founding, the data sent back to user application. But what it was I'm saying here, when number of user requests or increases, your database burden also increases. When database burden is increases, performance-wise, degraded your database performance. So these kind of problems are generally we are going to be facing when we are working in real time. Such as the people, what they will do it here, whenever they want to work on databases, when user want to work on databases, they are creating one separate memory. They're creating one private memory. They're creating one workspace, okay, where I can go to do my operations. So that workspace, that private area or temporary memory is called as a cursor. So that's a cursor is called as a temporary memory or private memory or area and workspace. And here, this memories are the two types of memories are there. One is first one we called as a explicit memories, that is called explicit cursor. Second one is the implicit cursors. Implicit cursors. Okay, who was that? Explicit cursor is nothing but explicit means user defined. That means these memories are created by user. These are called as a system. These are called as a system defined. Okay, now so here two memories are. One is by itself your system is created, your cursor memory private area. One is user has to create. Okay, now so in this we will discuss now. My point we are discussing in this explicit cursors we are discussing. First explicit, later implicit. Okay, now implicit where the system, how the system is created, we will discuss. Explicit cursors user has to create. Why, sir? Why means that is I said just now. That is I just now. When user sending request, the request will go to directly like this. That's what it was happening, guys. Here, burden and performance will be degraded. So instead of going to interacting to database directly, what users are going to do to improving your database performance, improving their database performance, what they're doing, they're creating one private memory is created by user. One separate workspace is created by user. One separate memory, temporary memory is created by user. So how it is, okay, to create that kind of memory, then we have 4 steps are there, the steps you can observe. So as usual, your table data is storing under databases, right? And what is your first step is, first you need to declare cursor variable along with the select query statement. So compulsory select query should require. This is first step. In this step, what happened? Whatever you declaring cursor variable, on that explicit cursor variable, first it was allocating memory. Carefully observe red mark carefully identify, allocating memory. Okay, allocating memory, right? So, but allocating memory for your cursor variable, right? But this query is not execute. This query will not execute. Okay, now. So just variable is declared. We are declaring one cursor variable. That's it. And for that variable, once you declare, for that variable purpose, it was allocating some memory. Allocating some memory, right? Okay. But self command is not executed now. When it was executed, self query means a second step. What is your second step? Open your cursor connection. Open your cursor connection. Now here I'm going to open now this. See here some space, some here opening. Some opening is there. So whenever cursor connectivity is open, then immediately this select query is internally executed. That means this query request will go to server and server will executing that query. Based on the query request, whatever the query request you return, based on this query request, your Oracle server will go to database. And which table he wanted? EMP table. That EMP table data, complete data, because he is asking completely. Select a star from EMP means entire data. What it was going to do your server, it was taking from database memory and loading into cursor memory location. Okay, because cursor connection is open now, so your memory connection is open. Then select query executed, and based on select query request, your Oracle server will go to database memory and taking EMP table and loading into cursor memory. That like a transferring your data into cursor memory. So once the data comes under cursor memory, then what user has to do? Now you are going to be fetching your rows and data from cursor memory. So now onwards, every user request, that means now onwards, whenever user want to access, then every user request will go to where now? Cursor. So we are going to, every request is going to where now? Cursor. That means user request will not go to database. My point understanding now. Now, user no need to interacting with the database now, because already we created our separate workspace, and in that workspace, which table data you wanted for your work, for your requirement, that data already transferred from your database memory to cursor memory. By this reason, what happened? Next level, whatever user need to fetch data, fetching means retrieving, inserting, updating, deleting, this kind of operations, whatever you want to do, that he can interacting, that he can performing on explicit cursor memory table. So that means every user request now it will go to cursor, but not the database. Then what happened, guys, here? The number of user requests will be reduces. That point I given. We reduce number of user requests on database. So that means what happened? Database burden reduce, and once the burden reduce, you are improving database performance. Okay, now, so whatever you are fetching the data in this cursor memory, that every fetching of data, it was immediately updating to your original table. That's called a main table. That's called updating data into database. Okay, now, so now your work is completed. You are fetching data, your work operations are completed. Then user, what he was going to do, he was going to be closing their cursor connectivity. So you are already open now. You are already open now. So now what he was going to do, he was closing. Now you are closing. So whenever you are closing your cursor connection, at the time of closing, your memory destroyed. Your memory destroyed. Otherwise, vanished. Okay, so are you closing means are you destroying your memory? Because this memory is not a permanent. This is what I said, temporary memory. Cursor is a temporary memory, temporary workspace. So your work is completed, your operations are completed, then the data successfully updating into database table, then after that you can close. When you close your cursor, automatically this memory will be destroyed. And your data successfully updating into your database. After updating into database, then you can close your cursor. The cursor will be closed. It means destroyed. So that means what happened? Now every user request, where it will go? Cursor. That means you are interacting, user interaction with the cursor. User is not interacting to database. Now user interaction with the cursor, not database. So when user interacting with the cursor, not database, means database pressure is decreases. Come on, guys, what you say? Now your pressure is decreases. So your pressure is decreases means Can I say your burden is decreases now? Your burden is decreases means you having good performance now? Yes. So that is what explicit cursors are going to be created by user to avoiding burden on databases. Okay now, and to improving your database performance. Okay now, this is the purpose of explicit cursors, why the user has to create. And in this explicit cursors creation, there are 4 steps, guys, to create a explicit cursor. To create an creating or declare cursor variable. Syntax I'm giving now. The syntax is select query compulsory. After step number 2, open cursor. The syntax is open. So your cursor name. Step number 3, fetching row data. Fetching row data from cursor. Okay, now? So the syntax is fetch from cursors, where I have to give your cursor name, and fetching from cursor and storing into variables. Okay, general variables you have to declare here. The program I will show you that all. Okay, step number 4, we have to close your cursor. That is called a close cursor. So these are the 4 steps, guys, you should be remember whenever you want to create your explicit cursor memory, like a user defined cursor memory. Okay, now, right. So these are the 4 steps we need to follow to create explicit cursors. All are syntactical basis. Okay, all are formulas. Okay, right. And the next one is what now? Okay, fine, sir. We are creating, that's okay. But here, after creating data loading into cursor memory from database to cursor memory, later what I said, fetching your data. Okay, whatever the data you require, the data you need to fetch now. But whenever you want to go to fetching your data, okay, before fetching, first you have to know it whether in my cursor memory data is there or not there. In your cursor memory, data is there or not there. That I want to know it first of all. So how we can know it in your cursor memory, data is there or not there? So for that purpose, we have some attributes. Attributes of an explicit cursor. So these attributes, there are 4 types of attributes. One is called as a percentile is open attribute. Okay, it's a predefined percentile. That means before you have to go for the syntax, I will show you. So these attributes, how to use it. The syntax is you have to use that. Cursor name, percentile, your attribute name. This is your syntax. Okay, now right. So that's why I'm using percentile. Okay, percentile is open. This is what it was saying that, guys, here. It returns to when cursor connection successfully open. Okay. Otherwise it returns. Otherwise it returns what now? False. Okay. So when you are cursor connection or connectivity or connection will be open successfully, then this attribute return true. Otherwise, it return false. Otherwise, it return false. Okay, na? That is one. Second attribute, that is called a percentile found. This attribute is written true when cursor is having data. Otherwise, false. Okay, now? So when cursor is having the data, then it returns true. If it is not having the data, then this attribute returns false. Third one is percentile not found. Percentile not found return true when cursor is not having data. Otherwise, false. So it's a quite opposite of your, okay, it's a quite opposite of your found attribute. Okay, now? Right. And fourth one is called as a percentile row count. Percentile row count. Okay, now? So it returns, okay, number of rows fetching. That means how many number of rows are fetching. That will be written by row count. Counting, that means how many rows are, okay, retrieval, how many rows are selected, how many rows are fetched. So the number of rows, how many you fetching from your cursor, either 1 row, 2 rows, 5 rows, 10 rows, 100 rows, how many rows are you fetching? That row counting will be written. Okay, number of fetching rows, written number of rows fetching from your cursor. From your cursor. Okay, now? So these are the attributes, guys, and with the help of these attributes, you can go to these. With the help of these attributes, we can go to checking whether in your cursor memory data is there or not there. Okay, now? So that we will be check out whenever you want to retrieving data like a multiple rows data, whenever you want to retrieve, so there you can go to check and retrieve. Okay, now this is okay attributes of your explicit cursor report. And one example I will show you that here. One example. What is this? Write a cursor program. Write a cursor program to fetch a single row from EMP table. Okay. So now whatever I said, the 4 steps, guys, here carefully observe. Whatever I said, the 4 steps. Yeah, 4 steps is there. No? So same 4 steps I'm using now for my program. Let you see. Okay, let it come out. This is your table. So our working table is EMP. In EMP, there are so many number of rows we have it here. So from this table, suppose you need to fetch a single row from this table. How this cursor we are using observe. So first step is what now? Declared cursor. Cursor name C1 is a selected star. Yes, star means what now, guys? We have all columns, right? Star means all columns. That means we are retrieving, we are fetching all columns data from EMP table. That's the meaning. But here, how many columns are you selected here? That many variables we have to declare. That's the point of observe. That many variables you have to declare. Suppose star means here 8 columns are there, then 8 variables you have to declare. Otherwise, instead of that, suppose I need my required columns, the specific columns data I'm retrieving here. So in this statement, what I said, guys, here this is step one. In this step one, what I said, just memory is allocating for C1 variable. What is my variable name? C1. My cursor name is what? C1. On the name of C1, your memory allocated. Only memory allocation, but this query is not executed, right? After that, I'm declaring two variables for both which columns I selected for those columns purpose. Okay, some two variables I'm declaring. Okay, later begin. And after open click. Yes, here the point is, so whenever you open your connection, I said, whenever the connection is open here, then your select query executed and the data loading into cursor. So same thing here also done. What it was going to do? So once you open this C1 cursor connectivity open, then this query executed. In this query, whatever we written, how many columns data you wanted, especially those columns, that means ename column, entire 14, two columns are, and the two columns of data is retrieving from, that means transferring from your database memory to cursor memory. Okay, these two columns data transferring from database memory to cursor memory when you open C1. Yes, done. Now tell me guys, your e-name and salary column, these two columns data, okay, where it is now? Come on guys, your two columns data, where it is now? Where you stored? Storing under C1. C1 is nothing but cursor memory. Okay. So once open cursor connection, select query executed, whatever the columns you mentioned, those columns data transferring into cursor memory C1. Okay, na? Right. After memory transferring into C1, then user, what do you want to do next step of fetch? Fetch from C1 and those values, those column values and storing under v underscore ename comma v underscore add. Here, fetching, how it was fetching means the fetching starts with the fetching is always starts with the first row in my table, in my cursor table. But cursor table, what is there? E-name and the salary only there. So e-name, first employee name is what? Smith. Salary what now? 800. That means what happened? Fetching from first row. That means first row only fetching. The fetching starts from first row. That is the default. So fetching first row. First row's employee name, fetching and storing under VE name variable. First row employee salary, fetching and storing into V salary variable. Okay, only first row. Fetching from which memory? C1 memory, storing into variables, right? After storing those values into variables, now that values I want to print. dbms underscore output dot put underscore line of v underscore ename concatenate comma concatenate v underscore salary. Now I just enter, and after that I just give it here. What you want to, after printing, then you have to close your C1. Close your C1 means what happened? Only first row is fetching. Yes or no? Only first row, employee name and salary fetching. Remaining rows is there, but I'm going to do what? Closing. Closing is what happened? Your entire cursor memory destroyed. Your entire cursor memory is destroyed. So that means memory is destroyed means in the memory table data also lose, destroyed. So now that is when you closing. Okay, after closing, then you have to go for end your begin statement and exit. Then what is open spelling wrong? Okay, open spelling wrong. Okay, right. Now first row. What is your first row? Employee name Smith and 800. So that was we fetched out. Okay, that was we fetched out. So this is what happened. Single row data fetching. That's okay, fine. But tell me guys here, in your table, you have a single row or multiple rows? Single row or multiple rows? Yeah, multiple rows are there. Yes or no? In my cursor memory also 14 names are there. But out of 14 names, only first row only I'm taking now. Remaining 13 rows are I didn't take it. Yes or no? So this is what only single row. But in my table, not only single row, no, I have a 14 employees are there. So the 14 employees data I wanted. Then what we want to do, sir? What we want to do means, now you can observe. Each fetching statement, a fetching statement is always fetching a single row. It's a very important point. Okay, whenever user want to fetch the data from cursor memory, he can't fetch all rows at a time. So he can fetch, okay, we can fetch only one row at a time. So this is very important. From cursor memory, we cannot fetch more than one. So your fetch statement, whatever the fetch statement is there, by using this fetch statement, I can fetch only one row from cursor. One row only display. For example, let you see, if you want to understand, let you see. Now see fetch statement. One time I return, two times I return, three times I return, four times I return, five times I return. Now tell me guys, how many fetch statements I return? How many fetch statements I return? How many fetch statements I return? 5. So first fetching, printing, second fetching, printing, third fetching, printing, fourth printing, fifth printing, and finally I just close. And now what happened? 5 times I return my fetch statement, then 5 times 5 rows are displayed. Then 5 times 5 rows are displayed. So that means now understand now. So every fetching of a row from your cursor, how many rows we can fetch here? Only one row. Only one row. And now tell me, if I have a 14 employees are there in my table, then are you writing 14 statements? 14 times are you writing your fetch statement, guys? Come on. No. For example, your table is having 1 lakh rows are there. Then 1 lakh rows are you fetching purpose? Your fetch statement are you writing 1 lakh times? No. Then what we can do? What we can do now? How to fetch multiple rows? Is there any idea? Yes, very good. Loops I want to use. Looping, that's called iteration statements I want to use. Like we already there now, simple loop, while loop, for loop. So these looping statements I have to use to fetch multiple rows from your cursor memory. Okay, now, but how? Okay, how to fetch multiple rows, collection of rows. So that we will see in tomorrow's session. In tomorrow session. Okay, now. Right, guys. And guys, here already we are already discussed. Okay, so already new batch was started today, 7:30 p.m. So that's why your batch was postponed to 8:30. Okay, now. Okay, so do one thing. I will give this is one choice for you. So who want to moving? morning 7:30 a.m. That kind of possibility, which students are there? So some last time I asked, some students are saying that, sir, I can go 7:30 a.m. sir, no problem, because I don't engage with any other batches. Yes or no? So if any student like that is there, and this is also your choice, same concept is going on. Okay, now. So up to here only there also happened. So that's why what I'm telling guys here. If in this batch, if any student, either 5 students or 10 students, whatever it is, if you moving, sir, I don't have any problem. I can happily move into morning 7:30 a.m. Okay, now if you have like that any student, you just happily move it. Okay, now. So who are not possible, so those people you can continue this batch. Understanding my point now? If it is possible, move it. If it is not possible now, then you can continue this batch. Like anybody is there, just tell me guys here. Just raise your hand. Just raise your hand. Only raise your hand. Okay, Vaishnavi. Okay, Surendra. Sabash. 4, 5 students. Shashi Kumar.